Hello everyone, welcome to this recording on Norton equivalent circuits. So as previously discussed with Thévenin equivalent circuits, the objective of this section is to obtain a much more simplified representation of an otherwise complicated or complex looking circuit. So previously we looked at this complex circuit and we indicated that it can be simplified to a single voltage source VTH, a resistance RTH, which is the equivalent resistance, and the original load resistor connected at the load terminals AB. Similarly, the same complex circuit can be simplified to a current source that is connected to a load resistance, which is termed Rn, and in parallel connected with the load resistor from the original circuit. Now, what is IN? IN is known as the Norton equivalent current. This is defined as the maximum current through the load resistor. Rn, on the other hand, is known as the Norton equivalent resistance, which is the resistance looking into the circuit from the load terminals. If we take a look at the transformation from the Thévenin equivalent circuit to the Norton equivalent circuit, there is a couple of deductions that we can make. First of all, one should be able to see that this circuit is equivalent to this circuit. So the Thévenin equivalent circuit is equivalent to the Norton equivalent circuit, and you can prove this through source transformation. The voltage source in series with a resistor can be transformed to a current source that is in parallel with the same value resistor. So what does that tell us about Rn and Rth? It should tell us that the value of Rn will always be the same as the value of Rth. So therefore we know that Rn will always equal to Rth. And if we were to determine In, say we had calculated the Thévenin equivalent circuits, we can then determine Rth using Ohm's law to say that In is equal to VTH divided by Rth. So let's take a look at an example. So if I have a circuit similar to the previous section of 10 volts, 8 ohm resistor, and I define my load resistor as 2 ohms. And I would like to determine the relationship between the load resistor and the current going through the load resistor. I will pick up that if I determine this current, IL, that will give me 10 volts divided by 8 ohms plus 2 ohms, which gives me 10 ohms, which will give you a current of 1 amp. So for a load resistance of 2 ohms, I get a current of 1 amp. What did we define the Norton equivalent current as? We said this is the maximum current over the load resistor. So if I want the current to be maximum, what should happen to the load resistance? You'll remember the relationship between current and resistance. I is equals to V over R. The higher the resistor, the lower the current. What would I like to do? I'd like to maximize my current. That means my resistance must be as low as possible, and the lowest value we know is going to be 0 ohms, which in electrical terms will be a short circuit. So the moment I'm able to replace that circuit with an equivalent circuit where the load resistor is replaced with a short circuit, the current that I will calculate there will then be my Norton equivalent current, which is the maximum current. So in this case I will say I Norton is going to give me the full voltage 10 volts divided by 8 ohms. Alright, and this value when the load resistor is 0 ohms will then be 10/8, which as we can see is larger than the 1 amp that is indicated there. So, to find your Norton equivalent resistance, first you need to detach your load resistor if it is already in the circuit. Then you need to deactivate all independent sources. This means, once again, a voltage source becomes a short circuit and a current source becomes an open circuit. Finally, you will find the equivalent resistance looking in from the output terminals. To find the Norton equivalent current, you need to disconnect the load and replace it with a short circuit. So wherever you're going to have a load resistor that's connected, you will have to then disconnect it and replace it with a short circuit. The Norton current is usually the current that will be flowing in a direction to ground. So that will be the direction of the Norton current, mainly because it is assumed that current will flow from a point of higher potential to a point of lower potential. Activate all independent sources. So you would then need to ensure that your voltage source comes back into the picture and your current source comes back into the picture. Short circuit to voltage source, open circuit to current source. Finally, find the equivalent current through the short circuit. Thank you for watching this video and enjoy the course.